Hi guys, this is our first video about operational amplifier. Today we are going to learn about what's meant by the OPAMP and what are the major theories and major things we are assuming for an theoretical OPAMP. So first of all, you need to understand OPAMP is a circuit which consists of many transistors as well as many diodes and many other resistors which will bring a certain type of action from that op-amp. So op-amp is a circuit consisting of these many types of instruments of inside it. But here we are not going to study about what are the instruments inside op-amp or other things. Here we are going to study about how it's going to operate. If we give this input, what's going to be that output? So we are going to learn about the outside functionalities of that op-amp. We are not going to see inside. If you are new to this expert tutor channel, please don't forget to subscribe. Let's move on to the session. So here let's look at the characteristic of ideal op-amp. So this is a kind of a circuit, it's a kind of a diagram of op-amp. Here we are going to give two input voltages. This is going to be the plus. As you can see, it's going to be, we are going to call this port as V plus and the next one as V minus. Here we are going to give the input. We need to give two inputs. One is going to call V plus and another one is going to call as V minus. And the important thing is the VO, it's going to represent voltage output, which means here we are going to give this input. At the same time, we are going to get an V output. So here comes the question where this op-amp is going to get power, how it's going to get the power. So for that purpose, we are going to give a power source from these two ends. One is plus VCC and another one is minus VCC. It's not going to give any input over here. Here it's like a power, it's going to provide the power for this op-amp. When we are considering about the output, it's going to purely depend on this V input, but actually it's also dependent in this voltage limitation, the power we are going to give as an input. So this is the main thing. Here we are going to give the input in two ports like V plus and V minus, and also we are going to get an output, V output. For amplification, actually the op-amp means it's going to amplify the power. So for that amplification, it's going to use the power we are going to provide with VCC and minus VCC. So this is for power and this is for input. Let's say you are going to give something called 0.01 voltage. And also we will consider the difference between these two voltage inputs. Let's say this is known as VID, which is known as differential input voltage. This is known as differential input voltage. When we are giving that input voltage, we will consider the difference between those two voltages. What op-amp will do is it will give the amplification from that difference between those voltages. Here you can see VID is equals to V1 minus V2. Here V1 would be V plus. So these are similar names. For V2 we will normally denote as V minus. So V plus minus V minus is going to be the input, differential input voltage of that op-amp. It's going to be the input. And here you can see V naught is equals to AVD, a constant. Differential voltage gain of that amplifier. It's going to be a constant into the differential voltage as an input. So it's going to multiply the differential input voltage by a constant and it's going to provide the output. So let's say if you are providing the VID, which means let's say you are providing V plus with 0.01 voltage and V minus with 0 voltage. So how to calculate the output is you need to simply deduct these two and you are going to get a value 0.01. Always remember we will deduct from plus to minus. So that's how an op-amp works. So V plus minus V1 is going to be 0.01 voltage. There they will be providing the AVD value. And also you're receiving many types of things, so you can easily learn how to calculate the AVD. A constant. So let's say the constant is here 100. So you can easily figure out the output voltage is going to be 0.01 into that 100. Let's say it's going to be 1 voltage. So the thing is, here we are giving an input of very small amount, 0.01, but we are getting 1 voltage. So how it comes like that? For that purpose, we are giving this source power. Let's say we are giving up to 2 voltages. So from these 2 voltages, it's going to be minus 2. Oh, you can ground this. So let's say I'm putting it as minus 2. So here we are giving a voltage up to 2 voltage and minus 2 voltage. From that, you can see the input voltage is given very small amount of voltage. The small amount of voltage is going to get amplified using the source voltage we are giving, but it's giving a 1 voltage. If you are increasing this amount, it's going to increase, the V naught will be increasing. But always remember, there will be a limit, because we are only giving 2 volt and minus 2 volt. It's going to give a difference of 4 voltages, or else you can simply say that this is 0. So here we are giving only 2 voltages. The source power is going to give a provide with the 2 voltages only. So if you are giving the 2 voltage, it can only maximize the output voltage, can be only reach up to 2 voltages, because we are only giving 2 voltages. If you are giving the source power as 2 voltages, even though if you increase the V input up to a certain limit, let's say you are increasing up to 1 voltages minus the V plus, let's say the V plus is 1 voltage, and you are providing V minus with a ground, so the differential input voltage is going to be 1 voltage. If you use this AVD, let's say AVD is 100 and also the VID is 1 voltage. So theoretically we need to get 100 voltages. But however, we are not providing that much of input power for that. So that amplifier can't do that work. It's going to limit that voltage up to 2 voltage, because they can't increase the voltage after that 2 voltage. But remember, theoretically, we will take as the gain as infinite. So normally we are getting a value for this, but theoretically we will tell, if you are using an op-amp, it's going to give an output as infinite output, because we will take the AVD as infinite. But in actual condition, it won't be like that. It will have a certain limit. So these are the major things you need to know. And another basic thing about the current is, op-amp won't get any input current. That's a special characteristic of an op-amp. We will take as 0 for theoretical, but in practical there might be very little amount of current from the input of this op-amp. So these are the basic things you need to know. But here, although it's not taking the current, it will provide the current from this side output, because we are giving the another side source power also. So from that also they can draw the current. But when you are considering about the input, we will take, theoretically we will tell that input current is nearly 0. And also another important thing is, you might have whether there are any connection between these two V plus and V minus ports. The thing is, we will take that as infinite impedance, which means V plus and V minus are not connected. Let's say it's going to be like this. This is V plus and V minus. There are no connection between these two. So likewise we will consider, but in practical there will be an resistor which is going to be very high value, so that we can take that the impedance of this resistor is very high, so that V plus and V minus are disconnected. We will take like that. And also there are many characteristic which might be a surprise for you. when you are learning about the op-amp. So from the next video, we will try to figure those two. Thank you for watching. I hope this video will be clear for you. If you have any doubts, please comment it below. Thank you for watching.